Part of allocation problems. This is what we call a bipartite graph. Bipartite graph. And why is it called bipartite graph? Because it comes in two, which is what bi means, parts. Now, normally what we're trying to say here is maybe on the left we have people, on the right we have tasks, which means jobs or things to do. And we're trying to allocate, which means give the people to the tasks. And it can only be one-to-one. So one person gets one task. Not one person does two tasks or two people do one task. Must be one-to-one. And because it's one-to-one, you can see straight away, if you've only got one arrow, like this one, then B must be getting W. There's no other choice here. So our first easy part of the allocation is that B gets W. We have no choice about that. But following through on the logic there, if we look at this, A has got two arrows, and he's got one to W, but we can't do that because we've already given W away. So we can't do that one. We must do A to Y, and that's our next allocation. Again, no choice on this. So A gets task Y. Now, so we've already used up A, B, W, and Y. That leaves us that C could go to X, or C could go to Z, but also D could go to X, or D could go to Z. And that gives us two options. Well, actually, in bipartite graphs, you can do one or the other. Since they're both possible, we could do C gets X and D gets Z. Fine. But if we did it the other way, it would work out fine with the numbers. We'll look at numbers in another video. Now, we had to say B to W, A to Y. No choice about this. But we could have done C to Z and D to X, and that will be fine. And we've allocated one person to one job with two possibilities. Not many actual questions about bipartite graphs. You still need to use them when you do the Hungarian algorithm, but let's have a quick scan of our thing. Now we've got 5 things here, but we can see that Peter must get task 5, and Mandy's only got 1 error, so Mandy must get task 4. So straight away, even before we've even answered the question, looked at the question, so we want to find out who gets task 4. Well, it's Mandy. Oh, that was quick and easy, wasn't it? Let's allocate the whole thing while we're at it. What the heck? So we already said Mandy gets task 4. We already said Peter gets task 5 because there's no other arrows. We can also see, oh, there was another one. Oscar must get task 3. And then if you think about this, Lee can't do anything. He can't do task 4 because we gave that to Mandy. So Lee must do task 1. And, well, you know, don't have to do any highlighting here. Nola must do task 2, even though she's got 2 arrows. But fairly straightforward question. It's question 1. It's the on a multiple choice exam, so that one's going to be the easy one. Hopefully most people got that right.